Good afternoon, everyone, and welcome. Can you hear me? Good. I am Betsy Humphreys, Deputy Director of the National Library of Medicine and one of the many medical librarians across the country fortunate to have been trained, encouraged, inspired, and run ragged by Dr. Joseph Leiter, NLM's first Associate Director for Library Operations. The Joseph Leiter NLM MLA lecture was established to stimulate intellectual liaison and dialogue between NLM and the Medical Library Association, and we are very pleased that MLA's president, M.J. Toohey, is here with us today. You want to wave so people know who you are? This year's lecture is the first since Dr. Leiter's death at age 90 about a year ago. We are particularly delighted that members of his family are able to be with us today, in some cases having traveled a considerable distance to get here. So a special welcome to Joe's sons, Dr. Andrew Leiter and Everett Leiter, his daughter-in-law Ellen, and his niece Sarah Lewis. You were looking at one of my favorite pictures of Joe, taken around the time of his retirement in 1983 after about 18 years as NLM's Associate Director for Library Operations and 45 years of federal service in all. A biochemist, Joe had already had a long and distinguished research and administrative career at the National Cancer Institute before he was recruited to NLM in 1965, in what was certainly a rather dramatic career change. Many thought that NLM's director, Dr. Martin Cummings, had taken leave of his senses to bring in someone with no library experience to direct NLM's internal operations, but it soon proved to be an absolutely inspired choice. I think Marty Cummings recognized that Joe had been hugely successful in ramping up some important programs for NCI using contracts and basically taking operations that really needed to be scaled up and getting them on the way in a very effective way. And he felt that that was just the point that NLM was facing in 1965 as we began to inch toward the online era and we were developing the National Network of Libraries of Medicine, all of which increased service demands and operations across the country and meant that NLM really had to get up to speed and do things more rapidly and in a more systematic and well-organized manner. So basically, Joe was instrumental in managing to do all of this, and he essentially ushered us into the online age, automated internal operations at the National Library of Medicine, helped to establish the National Network of Libraries of Medicine, and really focusing on strong service tradition, brought to everything a view of what can we do to serve the user, and he didn't care too much about traditions of librarianship. He cared a whole lot more about getting products to users. And he also was tremendously important in promoting the development of medical librarianship, both in really scaling up online training across this country so that training was provided to librarians working in hospitals as well as academic medical centers, and through NLM's postgraduate associate program was a personal mentor to many, many people. So I am myself greatly indebted to him. I think he has had a major impact on my career as he has on the careers of many others. It is obviously a great pleasure to have such a distinguished person giving the 23rd Leiter Lecture, and I am going to ask Dr. Lindbergh to come up here and introduce him.
Well, welcome all to the Leiter Lecture. I suppose it goes without saying that Tony Fauci doesn't need much of an introduction at NIH, but I'll introduce him anyway. I'm remembering the first time I met him. I had just come in 1984, and I was invited by Jim Weingarten to some sort of a fine luncheon for a visiting dignitary. And he seated me next to Tony and said, "You should meet Tony Fauci. He's going to be the new director of NIAID. He's terrific." And he was and is. So that was, I've forgotten who the visiting dignitary was, but I've never forgotten meeting Tony Fauci. And I recognized that he was another Brooklynite, and I had just seen a whole lot of films of people vilifying him down in Greenwich Village. And I said to him, I'm not sure how you put up with this stuff. And Tony gave me good advice. He said, Don, don't take it personal, and don't get angry. Very, very good advice. So it is characteristic of Tony that he not only has run this huge NIAID plus HIV on top of that, plus bioterrorism on top of that, but he's run it all with a, seemingly anyway, great equanimitas. I mean, he's exercised personal good scientific judgment. He's led a huge bunch of people. He's continued to hold the respect of everybody at NIH, and has not taken it personal and not gotten angry, at least to my knowledge. I have to say that in my own opinion, he's worth 3 institute directors, and you can take your choice. I don't think I'll take any more time from Tony's lecture. I should say, of course, that he's trained in medicine at Cornell in New York, and then New York Cornell Medical Center. He came to NIH in '68. He was named director of NIAID in '84. And he's done a fantastic job for us and for the country, and I stand in awe of all that you stand for, Tony.
Thank you, Don, for that very kind introduction. It's a great pleasure to be here with you this afternoon to deliver the Joseph Leiter Lecture. As you can see from the title, I'm going to talk about pandemic influenza, but before I do, I want to put it into the broader perspective of emerging and re-emerging infectious diseases, because there really are very close links between the apparent or real crises that we're facing now in our preparedness for pandemic influenza and the fundamental principles that drive our preparedness for virtually all emerging and re-emerging infectious diseases. Don just mentioned that I was trained in internal medicine at Cornell, and I can't forget at all, very vivid in my mind, at the time when I was going to come down here to the NIH. In the mid-'60s, there was now clearly inaccurate and inappropriate perception among some, manifested by this quote from Aidan Cockburn on a treatise that he wrote on the evolution and eradication of infectious diseases back in 1963, which now we can call a premature declaration of victory over infectious diseases, where he said we can look forward with confidence to a considerable degree of freedom from infectious diseases at a time not too far in the future. Indeed, it seems reasonable to anticipate that within some measurable time, all major infections will have disappeared. Now, at that time, a few years later, in 1968, the Surgeon General actually made a similar statement saying we can kind of forget about infectious diseases and focus on chronic illnesses such as cancer and heart disease and others. And I tell this story all the time when I talk about emerging infections. It was exactly at that time that I was leaving my internal medicine residency on my way to Bethesda to do, of all things, an infectious diseases fellowship. So you can imagine how I felt when everyone was telling me that my subspecialty essentially was going out of business. But unfortunately for the world, and somewhat fortunately for me, at least in my career choice, even surgeon generals and great scholars are in error. Because now we fast forward well over 25 years, 30 years, and you see that even this past year, infectious diseases comprise 26% of all the deaths worldwide. And if you look at the statistics, it's the second leading cause of death of all causes. It's the first leading cause of death among young people from birth to 49, and it's overwhelmingly the leading cause of DALYs, or disability-adjusted life years, which really means years of illness. Now, how could that be in this era of modern technology, with vaccines, with antibiotics, with very precise diagnostics, that we still have infectious diseases as a great disease burden? It really is a complex and complicated scenario, starting off with what I call the matrix diseases, the diseases that have been there for a very long time, which really comprise the major burden, such as respiratory infections. Now, I have HIV/AIDS on there, but as a matter of fact, HIV/AIDS, as you'll see in a moment, started off as a new emerging disease and has now, 25 years into the disease, has established itself as one of the staple matrix diseases. Then there are the diarrheal diseases, tuberculosis, malaria, and if you look at the death burden there per year, it's really quite impressive. Now, superimposed upon these diseases are what we call emerging and re-emerging infectious disease. And this is a very busy slide, and so I apologize for it. But I really did it deliberately to impress you with, this is a slide that I show before the Congress every year when we talk about the budget for the Infectious Disease Institute, and I talk about, over the past 30 years or so, the number of newly emerging, re-emerging, and deliberately emerging diseases. Let me explain what I mean. I'm going to give you a few examples of them over the next several minutes. Newly emerging means a disease that was never before seen. The biggest and most impressive prototype of that is HIV/AIDS, another is SARS. Re-emerging is a disease that's been around for a while, but it reappears either under a different form or in a different geographic location. And West Nile virus for us here in the United States is a perfect example of that. And then finally, there is the disturbing issue of deliberately emerging microbes, and I'll spend a minute or two talking about that before we get into the current threat, namely influenza. It is of note that a few weeks from now will mark the 25th anniversary of the first report on June 5th, 1981, of the first cases of what then turned out to be HIV/AIDS in 5 gay men from Los Angeles who presented in a puzzling fashion with pneumocystis pneumonia, a disease that we only saw in people who were immunosuppressed. At that point in time, I had already been at the NIH for several years, because as Don mentioned, I came in '68 for 3 years as a fellow, went back to New York as chief resident of medicine, and came back in 1972 and began studying the relationship between host defenses and microbes, because I was trained in both infectious diseases and immunology. So already I was at the NIH as a senior investigator for 9 years, and I had seen a lot of pneumocystis, but it was only when I was doing consultations for Cancer Institute patients who were being immunosuppressed with chemotherapy. I remember very clearly being puzzled by this. 1 month later, on July 4th of '81, we began to really get anxious because there was about 40 additional cases from New York, LA, and San Francisco of gay men not only who had pneumocystis pneumonia but also Kaposi sarcoma. And that was the beginning of what now historically has turned out to be one of the most important pandemics in the history of civilization. Because if you fast forward 25 years, we know now there are 40 million people infected and living with HIV, 25 million have already died, and there is really no end in sight. This is truly the classic prototype of a new emerging disease. The NIH and other institutes have responded in a rather robust manner. If you look at this, this is when I came as director of NIAID, and this is the NIH's research funding for HIV/AIDS. To the point now, it is a little bit more than 10% of the entire NIH budget. I want to get back to that in a moment because it really serves as an example of what you can accomplish if you put concentrated resources into a particular area. The results have been striking. If you look at the advances in AIDS research since the first meager funding in 1981 to the present time, it really reads like a textbook of success, despite the fact that the epidemic still rages. The etiologic agent was discovered, diagnostics, molecular virology, the pathogenesis, understanding natural history, and importantly, a really concrete example of success was treatment, and I'll get to that in a second. This is a list of the FDA-approved drugs for HIV, more than 20 approved antiretroviral agents. This is important because this represents more antiviral drugs against HIV than the sum total of all of the antiviral drugs against every other viral disease combined. And that is really very impressive statistic, because it tells you what happens when you put resources in and direct them to try and do screening and targeted drug development. With that, the results were impressive. This is the number of newly diagnosed cases of AIDS. These are the number of deaths. The green circles are people living with HIV, and the reason that is going up in the United States is because as we're decreasing the deaths, we have a constant number of people getting infected each year, about 40,000, and that is very depressing even today in 2006, and we really need to do something about that. Now, drugs were good and clearly showed they could really transform the course of HIV, but they were only available for a while for people in the developed world, like the United States and Western Europe, Australia, Canada, etc. It was only a few years ago that President Bush initiated the Emergency Plan for AIDS Relief, referred to as PEPFAR, for the President's Emergency Plan for AIDS Relief, which was a $15 billion program over 5 years, aimed at treating 2 million people, preventing 7 million infections, and caring for 10 million HIV-infected individuals, including AIDS orphans. This, together with the Global Fund to fight TB, AIDS, and malaria, as well as individual bilateral agreements, has really shown another thing that was met with great skepticism. Could you apply modern public health issues, such as the delivery of drugs, in a sophisticated way to the third world? And the answer now, despite a great deal of skepticism, is yes, because just a few years ago there were literally a few thousand people in the developing world on antiretrovirals, and today, as of December of 2005, there is over 1 million people. So we still have a long way to go, but that's well beyond what people would have expected. Now, 5 years ago, this July, I wrote a commentary in the Journal of the American Medical Association called The AIDS Research Model: Implications for Other Infectious Diseases of Global Health Importance. And the point that I made in that particular journal commentary was that if you have robust financial commitment, human capital, namely the best and the brightest people getting involved, research capacity, including infrastructure, understanding the etiology and pathogenesis, you will have countermeasures developed. And the point that I made is that if we did this with HIV, although it cost a lot of resources, we could do it with malaria, we could do it with tuberculosis, and the point I'm going to make in a few minutes, we can do it with how we handle influenza, both seasonal and pandemic. So let me give you a couple of other examples of issues related to emerging and re-emerging infections. I mentioned that HIV is the prototype of the new emerging infection. Well, West Nile virus is the prototype of the re-emerging infection, because it had existed for centuries in Africa and the Middle East, and only in 1999, by some accident, probably bringing in an infected pet or bird or what have you, that we now have it in the United States, to the point of last year there were almost 3,000 cases and 116 deaths. So we have a new disease now in the United States that very likely will be with us indefinitely. And things like perturbation of the environment, how we act, a variety of other issues lead to the reemergence of new diseases. The research response to that was rather robust. They're listed here, with everything from developing animal models, basic research, antiviral therapy. But I want to give you one example of how now, as we are into the early years of the 21st century, we can rapidly respond. For example, with a vaccine which utilized the fact that we have a vaccine against the flavivirus, namely a yellow fever virus. What this group did, Tom Monath and his group at a campus, was to take the genes from West Nile and insert them into the backbone of an attenuated virus for yellow fever, winding up with now what looks like a very promising vaccine for West Nile virus. And then we have the issue of deliberately emerging microbes, something very unfortunate that we wish we did not have to deal with. This picture shows you what happened on September the 11th, and then what happened literally a few days to weeks later when the letters that were containing the anthrax spores were circulated both to our legislators, Senator Daschle, Senator Leahy, as well as some of our members of the media, Tom Brokaw and the New York Post. Although this was, relatively speaking, mild from a biological standpoint, there were 22 cases and 5 deaths. If you look at that, more people, many more people died of influenza, seasonal influenza, during that period than died of anthrax. But the special issue that goes along with bioterror is the fact that although the biological impact was minimal, 5 deaths, with all due respect to the people who suffered, 5 deaths are not a lot of deaths. The fear and disruption was substantial, as shown here in this picture, which was very typical of what we saw in Washington, D.C. in that fall of 2001, particularly around the issue of decontaminating the congressional and Senate office buildings during that period of time. Again, the response was rather robust. A considerable amount of resources were poured into preparing us in the arena of biodefense. These publications are examples. In the upper left is the Strategic Plan for Biodefense Research Agenda for the Category A, B, and C agents, which are agents of various priorities of potential for use in bioterror, as well as a number of progress reports associated with that. And we, I think, importantly, developed the agenda for biodefense so that it was very heavily based in fundamental basic research. And the importance of that is that it could be extrapolated to virtually any emerging and re-emerging infectious disease. Because if you directed your efforts only at an anthrax vaccine or a smallpox vaccine, and you don't delve into the fundamental basic research that allows these advantages, it would be difficult to be able to extrapolate that to other diseases, emerging and re-emerging. So we deliberately planned it that way, and in fact we have good examples of some of the infrastructure that was developed, such as some of our containment facilities, as well as the regional centers of excellence. And note, we call them the Regional Centers of Excellence for Biodefense and Emerging Infectious Diseases, not just biodefense. And these are now being used to have investigators have the capability of addressing other of the emerging and re-emerging infectious diseases. We just dedicated last week on campus the C.W. Bill Young Center for Biodefense and Emerging Infectious Diseases will serve to consolidate the human capital of investigators who are involved in emerging and re-emerging infectious diseases right on campus, and we're doing that also in the extramural community. These are some of the accomplishments that I call low-hanging fruit, namely developing quickly or expanding our capabilities with drugs and vaccines against smallpox, anthrax, botulism, and Ebola. But I want to re-emphasize the important advances that are being made in the arena of biodefense are the fundamental science that's going into allowing us to respond to any emerging and re-emerging infectious diseases, such as SARS. You all recall SARS a few years ago. The first cases were first noticed but not reported in November of 2003 in the Guangdong province of China, and it was only in February of 2003, when cases were reported from Hong Kong, did we see the beginning of what could have been a catastrophic epidemic, but because of the nature of the virus and its relative lack of ease of spread, despite the fact that this was epidemiologically a textbook case of what can happen with an emerging and re-emerging infection, it in fact was self-contained by pure public health measures. So that in 2003, we had 8,000 cases with about 775 deaths, and after that, except for some laboratory accidents, we did not see any further SARS. However, what did happen was we saw what 21st century technology could do for us. Because, believe it or not, and it's true, that the example of a new microbe, the SARS coronavirus, first recognized in a mysterious illness to the point that you went from the recognition to the sequencing to the development of a vaccine in animals, testing it in mice, to a phase 1 clinical trial in humans, was the shortest interval in recorded history from the time you had a brand new disease with a brand new microbe and you went into clinical trials with a vaccine. That is very impressive and could not have been done without the technological advances that had been building up all the way back from the HIV/AIDS days and the biodefense days. Now I'm going to spend the rest of the time on influenza, because influenza, interestingly, fills two of the criteria that I spoke about. On the one hand, it's a re-emerging infection. Namely, each year we get a new seasonal flu that changes just enough to require modifying the vaccine, but not enough to pose a public health catastrophe threat. And then every once in a while, rarely, as I'll show you in a moment, we get a brand new influenza, which really qualifies not as a re-emerging infection, but as a newly emerging infection. Now, influenza A has been around forever. It is designated by the terminologies of H for hemagglutinin and N for neuraminidase. And there are many various combinations. There are 16 H's and 9 N's. So if you look at influenza, you've got to look at it two ways. There's the influenza that leads to seasonal disease. And again, that drifts. And by drift means, for example, for the last many years, we've had an H3N2 influenza that circulates. We changed the vaccine because it drifts a little from year to year, but it doesn't drift so much as to become something different from H3N2. It results in seasonal influenza. When it changes a lot, which we'll get into in a moment, then you get a pandemic influenza. So let's concentrate first on seasonal influenza. We, and I submit this to you, we as a society do not take seasonal influenza as seriously as we should, and it's for that reason that we find ourselves in somewhat behind the eight ball when it comes to preparing for pandemic influenza. There are 36,000 deaths per year. There are 200,000 excess hospitalizations in the United States, about 500,000 deaths globally, and tens of billions of economic cost in the United States. Yet, if you look at what we do for influenza, we haven't maximized our vaccines or our drugs. This is a typical seasons. This is 2003 and 4, where we peaked early and went down. This is 2004-5, where we peaked late and went down. And this is this year in red. At the end of the season, we have about the same number of influenza illnesses. These aren't influenza cases. These are influenza-like illnesses, of which are consistent, reproducible proportion of which are truly influenza. So we look at that and we say, well, it's not that serious, even though we have 36,000 deaths, 32,000 of them, 33,000 of them among individuals greater than 65 years old. That makes sense. If you're greater than 65-year-old, you worry about that. And if you're not, you say, we really don't have a problem, which I think is really not an appropriate way to address this very important problem. So how do we plan for seasonal flu? If you look at these numbers, the most that we have ever vaccinated on any given year is 83 million Americans. So the vaccine production industry is not geared up to make 300 million doses of vaccine, because we're not going to use 300 million doses. The best we've ever done is 83 million doses. We don't even know if we've maximized the immune response. We don't know if we can make it better. We don't know if we can get the 65-year-olds who only respond to the tune of about 50% to respond to the tune of about 90%. Why? Because we haven't pushed the envelope, because we don't perceive it as a major threat. However, we are going in the right direction. We plan next year to vaccinate as many as 120 million people. What is the goal? Well, if you listen to what the CDC says, and they're correct, that there are about 190 to 200 million people who should be vaccinated for a reason of a particular risk. The rest of the country should likely be vaccinated, because the more people you vaccinate, the greater the herd immunity and the higher the possibility of essentially not having an impressive influenza season at all. The same can be said for the antiviral drugs for influenza. We have two categories of drugs: the neuraminidase inhibitors, typified by Tamiflu, which is also called oseltamivir, as well as the M2 protein inhibitors, such as the adamantine derivatives. Again, we've not optimized our drugs. They do very little. They shave off 1 to 2 days of symptoms, and they have to be given within 24 to 48 hours of onset of symptoms. We would never accept that kind of performance for an HIV drug, but we do for an influenza drug. Let's take a look at what happens when there's a big shift. Pandemic influenza. 3 times in the 20th century, we've had pandemics. The one that was the most impressive and the worst case scenario was 1918, where more than 50 million people died. It's important to point out, for those of you who have heard me comment to the press about the broad range of what might happen, is that in 1968 we also had a pandemic, the first time we ever saw H3N2. But it really, in its effect, wasn't particularly worse than any seasonal flu. Yet it was a pandemic because it was a new virus and it was widespread. So the possibilities when you face pandemic can be anything from very mild to catastrophically severe. Why are we concerned now? Why is there all of this activity going on of concern about the possibility of a pandemic flu? It's the fact that more so than we've ever seen, there are viruses that are circulating among domestic fowl, particularly the H5N1, which first appeared in 1997 in Hong Kong and then came back with a vengeance in 2003. These are some of the covers of magazines over the past several months that are talking about the real potential for a catastrophe from a public health standpoint from pandemic flu. There have been over 200 cases and over 100 deaths. In the light blue are countries in which there are bird cases, either chickens or migratory fowl. The dark blue are countries in which there are actually human as well as avian cases. Now, some facts about this. Clearly, if you're a bird, you have a problem, because there is a pandemic flu among chickens. But it very rarely infects humans, and there's been only one documented case of human-to-human spread. So the potential for it evolving to be able to spread efficiently from human to human is there, but no one can give you a probability of whether or not or what the chances of that happening are. It may be that it's a dead end and it will never happen. In fact, that could be a likely scenario. But when you prepare, you have to prepare for the worst case scenario. And it was in this regard that I went a few months ago with Secretary Leavitt on a trip to 5 countries, Thailand, Cambodia, Laos, Vietnam, and Indonesia, to report back to President Bush about what the situation was in Southeast Asia. And there really is a difference. This is us. I mean, you can't recognize us. Here's me. Here's the Director General of WHO, J.W. Lee, and that's Julie Gerberian of the CDC there. We're dressed that way not to protect ourselves. We're dressed that way to protect the chickens, because we actually were going into facilities and we didn't want to be spreading any possible contamination from facility to facility. Here I am in Hanoi at what's called a wet market, and if you look here, you see how these chickens are all crunched together so that if there ever was a virus, they'll be very easy to spread. But this is the crux of what's going on in developing nations that people are concerned about. This is a hut where a farmer who's raising ducks and chickens lives. This is a pond where migratory birds land. And if you go in and take a picture, you see these people sleeping right next to the chickens that they're looking out for. So the commingling of humans with chickens is a perfect setup for jumping of species if, in fact, the chickens get infected. That happens in countries that are relatively non-industrialized. In Western Europe and the United States, even though we very well may see a migratory bird be identified in our country that's infected with H5N1, it is unlikely, not impossible, but unlikely that we will have massive contamination of chickens. This is a flyway pattern of showing how birds that are infected can either go over the Bering Straits to Alaska, that's why we have great surveillance in Alaska right now, and back down through the west coast, or over from Greenland to the United States. Now, if a migratory bird gets here, that's not the end of the world, because it is more likely that if we in the United States are going to be in danger, it will not be from infection from a bird. It will be if somewhere else, here or there, the virus evolved to be able to go efficiently from human to human, and then a human infection came by the standard routes, jet planes, people traveling. Well, what happened? So, these are the scenarios, and that's what confuses people. The moderate scenario, people talk about, you can have 200,000 people die in the United States. I hate to show these numbers because it's based on a mathematical model, and you can make the mathematical model do whatever you want the mathematical model to do. This is the worst case scenario, which is what you hear about when you talk about the possibility of 2 million people dying of pandemic influenza. Again, this is based on a mathematical model. Some of you may have seen the ABC movie last night, which was a breathless hysteria about what could happen in a pandemic. It was sort of interesting. It had I think some positive aspects that at least is bringing to the attention of it, but it made it seem like inevitably we were going to essentially wipe out the world. And as several of us commented, myself and Secretary Leavitt, after the show on Nightline last night, was that you have to prepare for the worst case scenario, but the general public, as I said, should not be going to bed at night, waking up in the morning expecting to see the single mutation that's going to destroy the world, because that's non-productive anxiety that doesn't help anyone. So how should you be preparing for pandemic? Well, this is a copy of the President's national strategy, which he announced at the NIH on November the 1st, followed by the HHS pandemic plan the next day, and just last week we came out with the implementation plan. The NIH is responsible for certain components of that, particularly vaccines and antivirals. Again, the research agenda is essentially the same as for HIV, biodefense, SARS. Very heavily based in basic research, so that you can do some of the things that even if we never have a pandemic, or certainly not an H5N1, what you do and what you learn can be used for preparation for what might happen 10 or 15 years from now. One of them, for example, is the recent discovery of reverse genetics. I don't want to bore you with this, but it's a way of being able to isolate a virus, and by taking the appropriate genes from that virus and getting the genes from a virus that grows well, for example, in eggs, you can really predict in a very consistent way how long it's going to take you to get a virus strain to grow in your vaccine. So instead of just waiting for random reassortments between these two, you actually take the genes, put it in a plasmid, and actually create the virus strain that you want. We also now, at the NIH level, run by NIAID in collaboration with a number of groups, including the National Library of Medicine, is a microbial genome sequencing component that sequences in collaboration with the Institute for Genomic Research and makes available these genomic sequences to all investigators. And we have well over 1,000 that are available now for investigators to study. The same holds true for what we need to do with drugs. We cannot accept a drug that only shaves off 1 or 2 days of symptoms and has to be given within 24 to 48 hours of symptoms. And it's for this reason that now we are launching on a very well-planned drug screening and targeted drug program to try and bring antiviral therapy to influenza to the level of what we're seeing, for example, with HIV/AIDS. Now, what about vaccine? Somewhat confusing to people are the issue of pre-pandemic versus intra-pandemic. Pre-pandemic means the pandemic hasn't occurred yet, but you isolated a virus that is threatening to be a pandemic, which is what we did. A couple of years ago, in 2004, we isolated a virus from a Vietnamese patient. We took that virus, made a vaccine, and we tested it first in young, healthy adults, then in the elderly, and most recently in children. We showed it to be safe and to induce an immune response that you would predict would be protective. That was the good news. The sobering news is that the dose that's required for that was prohibitively high. So we need to explore ways of amplifying that response. I'll get back to that in a moment. The intrapandemic vaccine we can't make now because we don't have a pandemic. And we don't know what virus is going to change to what form that would allow it to go effectively from human to human. When it does, then we have a limited amount of time to be able to essentially surge up our capacity. And there lies the rub about the vaccine production industry not being equipped to do that in a surge capacity. So what do we need to do in the meantime? What we're doing. Accelerating the development of other methods of growing the virus, like cell culture as opposed to eggs, where you don't have to rely on an inconsistent supply of eggs. We need to develop novel vaccine approaches, and importantly, and in my mind, one of the most important things is to evaluate strategies that we call dose sparing, namely adjuvants that could amplify the immune response. We have not applied those to influenza vaccinology, and we should have a long time ago. Some of you may recall that a few days ago, the Secretary announced $1 billion in contracts to develop a better way of growing live virus to make a vaccine, namely to convert the industry from cell-based, from egg-based to cell-based. But even more importantly, we need different strategies. We need to be able to bring influenza vaccinology into the era of recombinant DNA technology. Importantly, to get the appropriate antigens and put them in an immunodominant form to be able to induce an immune response that you would predict would be protective. But importantly, and to me this is the major goal, is to develop a universal influenza vaccine. By universal is one that you can actually stockpile, which is good against the strains that drift as well as the strains that shift, so that you don't have to play catch-up every year as well as crisis mode every 25 years when you're concerned about a pandemic. There are some scientific obstacles there, but I am certain that we can overcome them. So perhaps this activity and concern about pandemic flu is going to get us on the right track. I made that point very clearly in a commentary in immunity that I wrote in January of this year, in which I bemoaned the fact that with as important a disease as influenza, we have not called upon the knowledge that we have of the immune system to try and figure out ways to get a vaccine that would really protect against virtually any strain, which gets us back to the real issue, that we have to treat seasonal influenza the same way as we would treat a pandemic influenza. Optimize everything from drug development, targeted drugs, screening drugs, dissecting out the immune response capabilities of a pandemic, and ultimately developing a universal vaccine. And it's only when we do that, which we should have done a long time ago, will we be able to get out of crisis mode for the possibility of a pandemic. And finally, on this last slide, the reason why we know we as a community in infectious disease are really never going to go out of business, because it really is a perpetual struggle. Microbes have an extraordinary capacity to emerge, reemerge, and persist. It's part of their evolutionary capability. The only way we can keep up with them, with our capabilities, which is an intellect and a will, because they replicate every few seconds to minutes, we do it about every 18 years or so. So we're not going to evolutionarily outsmart them, but what we can do is we can use our capabilities in public health measures, in biomedical research, and technological advances. What we would hope to do is ultimately get to a draw. So victory is a draw, and by a draw I mean that we will be able to have the balance of our technologies to meet efficiently all the capabilities of microbes to emerge and reemerge. Be they a deliberate emergence such as anthrax, a brand new disease such as HIV/AIDS or the threat of a new disease such as that of pandemic influenza. Thank you.
Yeah. Sure. Dr. Fauci will take a few questions, no doubt handling them well. Any questions? How fast, I'd like to ask you about the cell-based vaccines. It sounds like that's a pretty important part of your strategy.
Yeah. Well, there are some companies that right now are already converting to cell-based. The reason cell-based, let me explain to you quickly why cell-based is important. When you grow vaccines, influenza, for a live virus to then ultimately kill and make a split virion or even a live attenuated, you have to get chickens that have to lay eggs, you inoculate the eggs, you harvest the virus from the eggs. It is tried and true and reliable. The problem is it has very little surge capacity. So if you're starting, you have to plan months ahead in advance. And if you need all of a sudden to make a change in midstream, it's very difficult to do that. If you have cell-based, you have vats and vats of cells in which you can grow virus, the same way as you grow different types of virus in cell lines. So if you need to change, you don't have to go back and back order another 100 million chickens. You can just go and essentially pull out another vat. So getting to cell-based is very important. The conversion of of egg-based to cell-based is something the companies don't have a lot of incentive to do, because if they were going to take a few $100 million and invest it, they would invest it in developing another blockbuster drug. So that's one of the reasons why the government has to partner with them to make it less risky for them to invest in that. And that was the reason for the $1 billion announcement that Secretary Leavitt made the other day.
So how many of those checks have you signed?
I didn't sign any of the 1 billion ones, but we're signing checks for the universal vaccine, the one on the last slide. Yeah.
I know this is a very simple question, but what can the average citizen do in any way to prevent or to work towards helping as a nurse or as a pharmacist, or what can we do?
Well, as we have said in many of we have a traveling road show, the Secretary and I and Julie Gerberding go around and talk to people about that, is that there should be plans. There should be a federal plan, state, local, business, educational system, and the individual family unit. I assume you're asking the question about the individual family unit. And what you should do is have a simple, what we call a catastrophe plan. What happens if there's anything? It could be a flood, a tornado, a hurricane, or a pandemic. How do you deal with interruption of services and interruption of supplies? What happens if you have a few children in school and both parents work? If they close the school, who's going to stay home with the children so that the other person can go to work? Has your school developed the capability of having internet homework back and forth? What about supplies of interruption? Your grocery store is closed for a couple of weeks. Do you have enough non-spoilable food around that you don't have to be worried about everybody going to the scene of gas station lines? What about if you have chronic disease, so you have someone in your home that requires daily medication for chronic disease? You don't want to wait till you get to the last pill before you go to the pharmacy. Sort of like you're going on vacation. You have an extra 2 weeks supply. Those are really simple, low-tech, non-historical things to do. If everybody has a simple plan like that, it'll be much, much easier.
Maybe push the button so we can hear you.
Why do people not get vaccinated, and what is being done to improve the vaccination rate?
People get vaccinated, I think, don't get vaccinated for a number of reasons. A, they don't perceive influenza as anything particularly serious to them, because influenza is often used in a misnomer sense. Like you get it to sneeze and you have a rhinovirus, say, I got the flu. You don't have the flu. If you have the flu, you know you have the flu. You feel sick when you have the flu. The fact that young, healthy people generally don't die from it. So people say, well, why do I need to get vaccinated? And also, I have to say that there are probably mixed signals from the public health community about people getting vaccinated. And what's changing now is that the CDC is being much more firm in their recommendations. Elderly individuals, people with chronic illness, children from 6 to 23 months. Just recently, the recommendation is also children from 2 to 5 years old, and now we're likely to go from children to 5 to 9. In essence, everybody should really be vaccinated. And if we were doing that, then the vaccine production industry will already have the capability of making between 2 and 300 million doses, so you wouldn't have to panic about what happens when a pandemic comes and you don't have the facilities to make the vaccines. You would already have it because you would be doing it every year. Yeah.
Yeah, when you are referring to a universal vaccine, did you refer to like a cell immunity-based vaccine, or are you referring to like a mixed?
I can't understand what he's saying.
Maybe speak up a little bit on that.
So when you are referring to a universal vaccine,
Yes.
are you talking about the cell immunity-based vaccine, or are you talking about the kind of mixture of different envelope proteins?
No, by universal, I'm talking about a vaccine that immunizes against the constant components of influenza that don't change. Two big targets are the M2 protein and the nuclear protein. The problem why it doesn't work under natural conditions is that they are not very immunodominant, so that when you get infected, you don't make a big immune response against M2 or NP. So what we're trying to do now is to put it in a very immunodominant form so that you can actually, the immune system sees it in a way that it makes a robust response to it. That's the direction we're going with that.
I ask you, I'd like to ask one other thing, if you might explain to the audience level 3, level 4 isolation, and why anyone at NIH or in the neighborhood would care about that.
Well, it depends on what side of the level 3 or level 4 you're on. When you talk about containment of doing experiments with microbes that may have a danger to the person working with them or to the outside community, there's multiple different levels, and it's called BSL for biosafety level. So you hear people talk about BSL 1, 2, 3, 4. There really isn't any BSL 1. This is BSL 1, where we are right now. BSL 2 is just a standard lab with a hood and nothing else. BSL 3 has very stringent requirements for filtering of air and suits and the availability of showering and not letting certain things in and out, having airlock rooms where you can't go into one room versus the other. The highest containment is a BSL 4, and that's the one when you see in the movies, the people walking around in the space suits with the respirators, and it's very difficult to work in a BSL 4 facilities. We don't have a BSL 4 here. We have one that we don't use. There's one up in Frederick. There's going to be another one up in Frederick. There's one in Rocky Mountain Lab. The building that I showed you, the C.W. Bill Young building, has the highest level as a BSL 3. So all it refers is to a different level of protection. Protection of the people who are doing the experiments and protection of the outside environment. Yeah.
During the SARS epidemic in Canada, there clearly was some issues with regards to the paramedics who were put on home quarantine or home isolation for a week and a half until they didn't get symptoms after they had carried a suspect patient.
Right.
Clearly, quarantine is a real hot issue here in the States because in Canada, where they have a single health plan, there's one direction as to what to do with those people, whereas in our community down in San Diego, where we have hospital discussions all the time, we have different hospital chains, they're private-based, and none of the hospitals really want to pay for people to not go to work for 10 days unless there's some directive from government, and I'm wondering whether there are discussions regarding what should be the policy in the private sector for people who are put on home isolation or quarantine.
Well, again, that will have to be decided depending upon the nature of the pandemic as it evolves, the number of people infected, the rapidity of spread. Generally, quarantine there's different kinds of quarantine, as you well know. Most people think of quarantine if any of you saw the ABC show last night, of forced quarantine, barbed wire fences and soldiers with M4 rifles. That's not really quarantine. I mean, quarantine, a lot of which is really voluntary quarantine. People staying home from school who who are infected people staying home from work. Quarantine generally can work if you're in the incipient stages of an epidemic and it isn't widely spread. Once something is spread within a community, quarantine, particularly with influenza, doesn't do any good. It just doesn't. It doesn't. In fact, that was one of the points that were actually correctly made in the ABC show last night. The governor of Virginia was quarantining everything, including himself, until he realized that there was so much disease around it was useless to quarantine. Yeah.
Can you say something? Can you say something about the informatics role in the development of vaccines, whether it's computer modeling of the vaccine and the disease, or tools that are currently available, or what you hope to get for a better approach to completing these vaccines?
Well, the modeling that's done is based on the various projections of the spread of a particular virus, what you call the RO, the reproduction rate of how many people would get infected from one person, and what kind of intervention would be best suited to interrupting the transmissibility. So there's a lot of some actually good models that were funded by the NIH of taking various scenarios and determining whether social distancing, antivirals, vaccine, or in what combination would be best suited to slow down or interrupt the transmissibility. So the answer to your question is yes, there's a lot of modeling done with informatics for that. Yeah.
The American public seems to have a large appetite for both complacency and alarmism. It seems to me the only way to fight complacency without being alarmist is to apply accurate and clear information, which seems to be one of the charters for the National Library of Medicine.
Right.
We've heard what we can do as individuals at the family level, but what more can the library be doing in a pre-pandemic situation, and more importantly, what more can we prepare for the intra-pandemic response? I realize news services and other people are in charge of actually disseminating the information, but collecting, preparing, and getting ready for this sort of thing seems to be something that is not uniquely, but at least part of our mission.
Yeah, I think the ease of information flow, I mean, you just said it. I mean, it's a great source of information, the library, figuring out ways to have that information disseminated in a convenient way, an easily accessible way, updating it, guidelines and things like that. That's what I would do. But I leave it to the experts. I just make the vaccines. You can.
Good for you.
Right.
Okay, thank you very
You're
much.
welcome. You're welcome.
Great. These guys have a certificate.